Welcome to this video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about TE waves in rectangular waveguides. So first of all, identify the difference between TE and TM modes from this picture. Here the transverse electric mode and transverse magnetic mode is given, and the wave propagation, direction of wave propagation is indicated by the green color arrow mark. So we can see that in the TE mode, in the first diagram, the electric field component is perpendicular to the direction of propagation. In the second diagram, the electric field component is present along the direction of wave propagation. So the magnetic field is perpendicular to the direction of wave propagation. So this is the difference. So first, in the first mode, TE mode, the electric field is perpendicular, so Ez component is 0 along the direction of wave propagation. So we can compare the two modes, TE waves and TM waves. So the electric field is transverse to the direction of wave propagation in case of TE, and H field only present in the direction of wave propagation, that is magnetic field only present, and these waves, TE waves, are also called as H waves or magnetic field waves, and HZ, HY and EY field exist and other fields are 0. So in case of TM waves, H field is transverse to the direction of wave propagation, so the electric field only present. These TM waves are also called as E waves. And Ez, Ex and Hy field exist, other components are 0. So for solving the TE waves for rectangular waveguides, we can use the product solution method, that is magnetic field component Hz equal to Xy. So where X is the function of X alone, capital Y is a function of Y alone. So using the wave equation for Hz, and the solution can be found as follows: Hz equal to C1 cos beta x plus C2 sin beta x, C3 cos ay plus C4 sin ay. Where the C1, C2, C3, C4 are arbitrary constants, we can solve these constants. So by applying the boundary condition, we can analyze the TE waves for rectangular waveguides. So the boundary conditions, are the conditions must be satisfied along the boundary between two different medium. So here we substitute EY and EZ 0 at x equal to 0 and x equal to A, and EX component and EZ component 0 at y equal to 0 and y equal to B. So by applying this boundary condition, we can solve the Hz. So the basic field equations are given by Ex, Ey, Hx and Hy. So these are the basic field equations. So in this field equation, we are going to substitute Hz value. So for Ex, minus j omega mu divided by h squared. Here we substitute Hz value, and we are going to differentiate using y component. So minus j omega mu by h squared. So in the second term, so when we are differentiating with respect to y, the change occurs in the second, third and fourth terms only. So for substituting Ex equal to 0 at y equal to 0, it is one of the boundary conditions. So we get Ex as minus j omega mu divided by h squared. So C1 cos beta x plus C2 sin beta x. So the third term is 0. So C4 into A. So to satisfy the boundary condition, the C4 must be 0. So therefore Hz becomes Hz equal to C1 cos Bx plus C2 sin Bx, C3 cos Ay. So substituting the second boundary condition, Ey equal to 0 at x equal to 0, we get Ey value. So my j omega mu by h square dou by dou x of C1 cos Bx plus C2 sin Bx, C3 cos Ay. So in this the terms, first two terms will be modified. So this is an activity. So next, at x equal to 0, we calculate Ey. So to satisfy the boundary condition, either C2 or C3 in the above equation is 0. So but C3 equal to 0 make the field vanish. So instead of C2 it is put equal to 0. So Hz becomes C1 C3 cos Bx cos Ay e power minus gamma Z. So we get Hz equal to C cos Bx cos Ay into e power minus gamma Z. So other fields are calculated in the similar method. Hx and Hy components are calculated by substituting the Hz values, and after substituting gamma equal to j beta, where a equal to m pi by a and b equal to n pi by b, the fields are calculated as Hz, Hx, Ex, Hy and Ey. So these are the TE wave components in the rectangular waveguides. These are the assessment questions. The wave in which the electric field is perpendicular to the direction of wave propagation, it is transverse electric. And the wave in which the magnetic field is perpendicular to the direction of wave propagation, it is transverse magnetic. And TE wave is also called as H wave. And boundary conditions for TE waves in rectangular waveguides. For waveguide propagation, the value of propagation constant must be equal to j beta. Thank you for listening this lecture.